Good afternoon, ladies and gentlemen. So we are starting with Unit 1 in Algebra 2, and it's all about graphing functions and transforming functions. So you'll notice throughout the course of this unit, we'll be doing a lot of graphing. Probably the most in comparison to what we'll do all year is really going to happen in this unit. The very first lesson is learning about parent functions. So just how we all come from somewhere. When we have functions that have different numbers and things like that, and they're really wide or really narrow or really tall or really short, when we have functions that fit some of those characteristics, they all originated from a very specific parent function. So before we can get into transforming functions and making functions really tall or really short or narrow, or shifted left or shifted right or moved up in the quadrant plane, we first need to identify where are these functions originating from and how are those transformations then affecting that original parent function to get this new picture. So today's all about parent functions. What I want you to do is there are 6 functions on this first page of notes, and I want you to give the name of each parent function listed, graph each function, and clearly indicate the units on the x and y axis provided. So this is where I'm going to recommend that you do a little bit of research on your own to learn about these. Some of these are going to be familiar, some of them are not going to be familiar. If you're wondering, well, how do I graph these functions? How do I even start? I will go through one of them with you, and then from there, I want you to pause the video and explore the others. Okay, so I'm going to go through one problem with you. Then from there, I want you to go and explore the others on your own. So we're going to go through this one. Just had to get my stylus. It says f of x equals 1 over x. So when you're graphing functions, there's a couple of ways you can do it. You can type it into a graphing calculator and look at a table, or you can create the table yourself. I'm going to go through and create the table myself. When I go through these, I often use the same set of x values because your x's are your input values. They're the numbers that you plug in for x. The y values, which is the same as f of x, are the numbers you get back out to then plot on your x and y axis grid here. The numbers I like to use are -2, -1, 0, 1, and 2. You can technically use any value of x. I like to stick with numbers that are a little bit smaller and easier to deal with because I don't plan on typing these into a calculator. But that's up to you. You could have chosen any set of numbers here for x. I usually choose about 5 numbers to make sure I'm getting the whole picture, but that's your call. So starting off with plugging in -2. That means I'm going to have 1 over -2 when I plug -2 in for x of my function. Well, that simplifies down to -1/2 or -0.5 if you think about it in decimal form. So plotting that point, -2, -1/2, I'm going to go back on the x-axis and down 1/2. I'm going to leave each increment as a tick mark of 1, so my point would be right here, back to down 1/2. Continuing that trend, if I plug -1 in for x, I'd get -1, plotting that point, brings me here. Plugging in 0, 1 divided by 0, if 0 is x, is actually undefined. So I'm going to shorthand that as UND to stand for undefined, meaning it does not exist. And if you were to type it into a calculator, you'd get this error message on your calculator because you're not allowed to divide by 0. Plugging 1 in, we'd get 1, and plugging 2 in, we'd get a +1/2 or +0.5. So plotting those points leaves us with this. Now, I decided to go through this one with you and have you explore the other ones because this is probably the most challenging one, and it's one that we won't get to really in depth until second semester, but it's still worth noting that it is a parent function that exists. When we connect these dots, we're actually not going to connect all 4 together because if you were to research or look up this function, it's called the rational function. That's its name. And when you connect the dots, you actually end up getting 2 pieces of a graph. that together make up the entire graph of the function. The reason why we end up getting these two curves here, kind of in opposite quadrants, are because of the fact that we can't divide by 0, and so it creates what's called asymptotes. Again, second semester we'll begin learning a lot about rational functions and asymptotes, so this was just more of a good refresher of how to set this table up to then get a graph. But this is the most we'll be dealing with rational functions for right now in this chapter. So if you're feeling a little perplexed by this, that's okay. Know that we have a whole unit dedicated to this later on in the year. But what I want you to do now for the other 5 graphs that are on this page, I want you to create a table, figure out a name, and then graph your points from the table onto the grid to get a picture. So take a moment, pause the video, and then press play when you're ready to see me walk through the other 5. All right, so you should have paused the video by now, and you should have these filled in. So I'm going to go through this, and here we go. So creating my table, again, I like to use the values -2, -1, 0, 1, and 2 because it gives me some positives and some negatives, and they're smaller values, so I don't have to do a ton of math or have to pull a calculator out or anything. I can do most of this in my head. Now, this function, f of x equals x, remember f of x is the same thing as y. They're the same thing. F of x is just function notation. Now, this is equal to x, so any number I plug in, it means I'm getting the same number back out. So that's why my x and y columns here look the same. Plotting these points, we get, a line. And that's because this is a linear function, which you learned a lot about linear functions back in Algebra 1. The next one, f of x equals x squared. This is the quadratic function. Again, creating my table. When I plug numbers in and I square them, this is where every year I have students making mistakes, so be careful. -2 squared is +4. You might be thinking, what, Mrs. Walker, that's not true. I plugged it into my calculator and I got -4. This is where you need to be careful. If I have -2 squared, like this, your calculator is going to read it as a negative times a 2 squared. Well, 2 squared is 4, and then carrying the negative down gets you -4. But that's not what this problem says. This problem, though it's not written, and I know it's been a while since we've probably had to think like this, so it's okay if you fell for the mistake. It happens. We're really doing parentheses around the -2, then squaring it. Because squaring something means you're taking that number and multiplying it by itself. Because there's a negative attached, that's why you have to be careful with your parentheses here if you're just going to type everything in. So again, squaring something means you're multiplying it by itself, which means we want to take -2 and multiply it by -2. And as we've been doing for years, we know that a negative times a negative is a positive number, and 2 times 2 is 4, so we get a +4 here. So that's why I get a +4 and a +1, and then my other numbers are positive still. Right? So that is the quadratic function. It creates a shape called a parabola. Sometimes think that this is called the parabola function. It's not. It's just the shape here is the parabola, but the name of it is quadratic. All right, next, f of x equals x cubed. I like this one because its name goes along with the exponent. It is cubic. And I use the same x values just about for all of these, especially just to stay consistent, so it's easy to see how the shapes of them change within the same grid. So, this one though, -2, when I cube -2, that means I'm doing -2 times -2 times -2. So I'm multiplying a negative by itself 3 times, which is going to give me -8. -1 cubed is -1, 0 cubed is 0, 1 cubed is 1, and 2 cubed is 8. This one takes me a little bit off the grid here. I always call this one the wet noodle function because when I was a kid, my aunt taught me that spaghetti noodles are done when you throw them and they stick to the ceiling. And this is usually the shape they would make when I stuck it to the ceiling. So that's always how I remember cubic functions. They kind of look like a wet noodle. All right, in the next video, you will see the second part of 1.1's lesson, and I'll go through graphs 5 and 6.